similar. Side angle side. If the angle of one triangle, I'm going to split up that group in the back if you can't get it together. If the angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides are proportional, that includes that angle, then the triangles are similar. So you'll see what I mean when we do this. Is either PQR or STU similar to triangle XYZ? Well, let's check STU first. Okay? So I'm going to go and check the side lengths and see if they're proportional. So SU goes to XZ. Do you see that? So, okay, I'm going to check 30 over 30. Let's see if that equals 15 over 15. So far it does. Okay. But then what's the last one? 20 over 25. So that does not work, right? You can see that this would be 1, this would be 1, but that would not be 1. So STU is not similar. Get it?
Yeah.
Okay. Grant, can you close your book for now, please? All right, then let's take a look at the next one, QRP or PQR. Let's check similarity here. So 30 is to 42. And then 15 is to 21. And then 20 is to 35. We're checking to see if those proportions are equal. So this is 7 over 5, 5 over 7. This is 5 over 7 when you reduce, and that's 5 over 7. So, which one is similar? PQR. Okay? So PQR is similar. By side, side, side. Let's say by side, side, side. Similarity. What? Did I write it wrong? You're right, it is.
Yeah, it'd be 21 over 2. Maybe. No.
Is this supposed to be 21?
It's 25.
This is 25, sorry. I knew it worked. I was trying to get through it quickly. Thank you for catching that. All right. Next page. Side, side, side. Let's see what this one does here. Find the value of x that makes XYZ similar to PQR. All right. So we're going to set up a proportion again. We have 3 sides, don't we? In order for them to be similar, their ratios have to be equal, the ratios of their sides. So this should have a minus here. It doesn't. I'm going to use these two here. 21 is to x plus 6 as 30 is to 20. So let's use our algebra skills to solve that. 21 times 20 equals 30 times x plus 6. Equals 30x plus 180. Subtract 180 from both sides, you get 240. And x equals 8. So, what I'm going to do is I'm just going to double check. This reduces to 3/2, right? Do you see that? 30 over 20, it reduces to 3/2. So if I plug in 8 here, right here, I would have 8 minus 2, which is 16. That would make that 18, correct? I'm just going to check to make sure that 18 over 12 reduces to 3/2. Does it? Yes. Then I know that 8 works. Got it? Because they have to have the same ratio. Have to be proportional. All right. That would be by side, 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 wouldn't it? Let's do this next one. You enlarge x, y, w to, so here's the smaller one, here's the bigger one, j, h, k. Is XYW similar to JHK? Well, let's see what we can prove here. We can either look for angle-angle, we can look for side-side-side, or we could try and prove side-angle-side. So what do I have right here? I have this, don't I? You see it? So I know those two angles are congruent, so I'm going to say, okay, angle W is congruent to angle K. I can't really tell about another angle. I can't. But I'm going to see if I can prove that these sides here are proportional to those two sides. So right down here they told me that XW is 16 and JK is 24. So I'm going to set up a ratio and see if this is equal to that ratio. 16 over 24. Does that equal, that's a question mark, by the way, 18 over 27. And when you reduce, you get 2/3 equals 2/3. Check, right? So, right now we're using which theorem? Side angle side. The side and the side with the angle in between is side angle side. Similarity. See it? Okay. Tell what method you would use to show that the triangles are similar. Well, just tell me, what would you use? Do you know any angles? No. So it has to be side, 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 right? Make sense? And it is. It works. So the triangles are similar by side, side, side. It will work. The scale factor is 3/4. Quick enough?
Quick enough.
Okay.